This is a continuation of the inventory management modeling lecture, and we had gotten down to using an example. As we had stated, there is a mathematical calculation that exists in order to determine the optimal quantity Q to order. And so if we continue down to the Good Buy example, Good Buy sells blank CDs for $5 per pack of 25. Annual demand is 1,200 packs. The carrying rate is 16% and the order cost is $12 per order. Currently, the store orders the CDs in quantities of 100 packs per order. So we are going to pull out our information where D is the annual demand of 1,200 packs, Q is the order quantity of 100 packs per order, S is the setup cost, or the order cost is $12 per order. H, the holding cost, was not given to us, but the carrying rate as a percentage was, so little h is 16% or 0.16, and our purchase price, or the cost, is $5 per pack. So purchase, actually they're giving us their selling price without giving us a purchase price. So we are using the $5 and assuming no profit in this example. So the holding cost is equal to little h times c, where 0.16 times 5 gives us 0.80 or 80 cents for the holding cost. Using this, we can go back to our equation. Again, IC is equal to our total annual inventory costs. IC is inventory costs. IC equals 1,200 divided by 100 times 12 plus 100 divided by 2 times 0.80. So just plugging in the numbers, we get a setup cost of $144 plus the holding cost of $40 equals $184, or the total annual inventory costs. If you compare these two, you'll see that the order or the setup cost is high compared to the holding cost. And our goal in the EOQ is to make these two more equal, which minimizes the total annual inventory costs. So once we have inventory costs, we can calculate the optimal order quantity, given by the equation the square root of 2 times D times S over H. Using our numbers again, D was 1,200 packs, so 2 times 1,200 times S of $12, all divided by a holding cost of 80 cents. Do the math, square root 36,000 gives us 189.74. We need to round up to 190 packs. So currently, ordering only 100 packs per order is nowhere near sufficient. They're ordering too frequently. So once we get the optimal order quantity, we go back and recalculate the annual inventory cost based on the number we just obtained. So we substitute in our quantity of 190. And sorry, I just paused my video because I noticed an error. Our quantity here, I did not change the 100 to 190. So I just updated that. So 1,200 divided by 190, which was, again, our optimal order quantity. And we substitute those two numbers in and do the math again. And you get 75.79 plus $76 equals $151.79. So you'll notice that the setup cost is a little bit more comparable to the holding costs. And this now becomes our total annual inventory costs. And if we pay attention here to our new inventory costs of 151 compared to our previous of 184, you see that we have lowered our inventory costs. So note annual setup or order costs and annual inventory costs. So just reiterating what I just stated there. So it amounts to a savings of $32.21. May not seem like much, but when you have multiple products and you do this for thousands of items, it adds up. So that is important and the goal of inventory management. And let's cover a couple of more, couple additional examples. For example, Paul's Pasta Pinwheels. Try saying that 3 times fast. The order quantity, current order quantity for Paul's Pinwheels is 200 boxes. The order cost is $4 per order. Holding cost is 40 cents per box per year. Annual demand of 50 boxes per year. In Part A, we want to calculate the annual holding costs plus the annual ordering cost to equate to the total annual cost. So we're using the IC inventory cost equation here when the order quantity is 200 boxes. From there, we want to go to Part B and calculate the optimal order quantity and the total annual cost for this order quantity. So start off in Part A, we're pulling our data out. Our demand is 200 boxes. Our order quantity is, our demand is 500 boxes and order quantity is 200. Our setup or the order cost is $4 per box. You'll notice that the holding cost is actually given in this, so we don't have to calculate the holding costs. There's a note there to call that out as well. Notice that S, the setup cost, is the same as ordering costs. So we take our numbers and plug it into the equation for IC equals demand 500 divided by order quantity of 200 times 4, the setup costs, plus order quantity of 200 divided by 2 times our holding costs of 40 cents. Calculating out, we get $10 plus $40 equals 50. So the setup costs plus the holding costs equals our total annual inventory costs. And if you just look, there is not a balance between these two costs. The holding costs are high, indicating that our order quantity is going to be high. We need to then calculate the EOQ for this item using the equation the square root of 2 times D times S over H. Plugging in our numbers, we get 2 times demand of 500 times $4 of setup costs over holding costs of 40 cents gives us the square root of 10,000, gives us 100 units. So currently ordering too many units. And we're currently ordering 200 and we should only be ordering 100. So we're ordering too many units. Part B, to recalculate the annual inventory cost based on our EOQ or the optimal order quantity of the 100 units using our equation. We're plugging in 100 in both of these areas, calculating out our setup costs and holding costs, both equal $20, adding them together is 40. So our IC of the EOQ is 40, which is less than our ICQ, inventory cost Q, of 50. So we are doing well because we're looking at 40, which is what we should be ordering, versus our $50. So in this, again, we're noticing that our ordering and setup is equal to our holding costs. Moving on to another example, the current order quantity for electric power bars is 100 bars. The order cost is $10 per order. The holding cost is 25 cents per bar per year. annual demand is 2,000 bars per year. Part A, we want to calculate the annual holding cost plus the annual ordering cost to get the total annual costs when using an order quantity of 100 bars. We want to calculate the EOQ and the total annual cost for this order, and how many orders per year are necessary when the quantity is 100. How many orders per year are necessary for the EOQ in part B. So first off, we're going to start with the 100 bars is our order quantity. Using demand of 2,000 bars per year, our order quantity of 100, our setup costs is, or setup and order costs, same thing, $10 per order. Holding costs, again, is given to us as 25 cents per bar. So we're going to use our IC equation, plug in our numbers, and calculate out 200 plus 1250. So setup costs of 200 and our holding costs of 1250. These two are not even close to being equal. Gives us a total annual inventory cost of $212.50. Very, very high setup or ordering costs. This indicates that our ordering quantity is too low. Part B, we need to calculate the EOQ for this item using the equation, plugging in our numbers of 2 times 2,000 demand times $10 of a setup cost divided by a holding cost of 25 cents. Take the square root of that, giving us 400 units or 400 bars. So 400 bars is the optimal, and we're only ordering 100 right now. So we're not even close to ordering enough, meaning that we're going to be ordering more frequently. So we need to recalculate the annual inventory cost based on the EOQ, or the optimal order quantity. So we plug in 400 here instead of our 100, calculate out, and we get $50 in setup costs and $50 in holding costs. So these are equal, giving us an annual cost of $100. So we see that $100 for our optimal versus our current of $212.50, we are definitely saving money, which is the goal of inventory management. Part C, we were looking at how many orders per year are necessary when the order quantity is 100, and how many are necessary for our results of 400. So if we have 2,000, that's our annual demand divided by our quantity. We will have 20 orders per year as compared to ordering at quantity of 400. We'll only need 5 orders per year. And this concludes the examples.